Okay, so let's get started with MapReduce today. Okay, this was today's session is a long-awaited one. We've been thinking about MapReduce right from first class, and there were questions there. So today is the time when we'll get answers to all those questions. So are you guys able to see the screen? Okay, cool. Thank you. Okay, so let's see what. So these are the things which we covered in the last class. Some of these configuration files. I'll not go into them. I just want everyone to look at this and feel that yeah, they know these things, right? We know about core site.xml. We know about mapred site.xml. We know about HDFS site.xml, slaves file, and masters file. Okay, so if you remember all this, very good. If you do not, then also it's fine. You can go back and revise that from the last class. Okay, so let's move ahead and let's see what are we going to cover in today's class. Okay, we'll try to understand where MapReduce is used. Okay, what were the traditional ways of solving problems which MapReduce is solving today in earlier days. Okay, we'll also understand how does a MapReduce program look like. We'll do at least 4 Java programs today. Okay, we'll show you 4 Java programs today at least. Okay, we will also discuss a little bit about Hadoop streaming. Okay, which is a way to actually run Java, run code without run MapReduce code without Java. Okay, so we'll discuss a little bit. We'll not go into the detail here. We'll understand the concept of combiner and partitioner, obviously other than the map and reduce. We'll also understand the data flow. We'll understand how the input splits are done, and then some of the input-output formats. Okay, so these are the topics we're going to cover today. It might be a slightly long session. I'll try to finish it in 3 hours, but in case I mean there are questions, we might extend a little bit by around 15-20 minutes. Okay, not more than that. It will not be a long one. Okay, it will not be a 4-hour session, that I can assure you. Okay, so let's get started, guys. Let's see where some of the applications, I mean, this is not an exhaustive list, but these are some of the applications where MapReduce is used today. Okay, and there is a lot of scope in other places as well where you can use MapReduce. Okay, so what I expect from all of you is that you keep on just keep typing on the chat window whenever you have a question or you are okay. So just keep on giving me a heartbeat without my asking you. Okay. Good morning, Amit. So Amit, we've just started 1 minute back. We just discussed about the list of topics. Okay, and now I'm just starting where MapReduce is used. Okay, so these are some of the use cases. Weather forecasting, and you have huge weather data coming from multiple sensors, and that data is kept at multiple locations, and you want to do a forecasting based on the data which you have. So you may have a data of the whole century, and you may want to forecast when the next monsoon will come or what will be the temperatures going forward. So this is one place where processing speed is very important. Getting good processing is very important, and MapReduce finds a utility there. Okay, we'll also see how traditionally these things are solved. Again, a very similar situation is in healthcare as well. Yes, Rahul is asking, can MR be used for predictions of earthquakes and tsunamis, etc.? Well, predictive analysis, yes, definitely. MapReduce will be the programming backbone to get that data and process it. What processing you want to do it, what analysis you want to do will be done by a front-end analytical tool. It could be R, for example, right? I mean, if people know about R is a programming language which is used as a front end to Hadoop these days. It's an open source thing, and that is actually used to do the analysis, predictive analysis. Okay, now MapReduce is used to crunch that data very fast, to get that data and do a fast retrieval of that data. Okay, we'll also see why MapReduce and why not other things. Yes, it can definitely be used to predict anything. Okay, it is not really MapReduce which is used to do the prediction. It is some other tool which will be used for the analysis. But MapReduce will help that tool. It will be the data store for that tool. Okay, to get the data from Hadoop. Okay, is that fine, Rahul? Now, the other utility of MapReduce is healthcare. Okay, where huge amount of imagery data is there, some video data will be there, different sensor data will be there. Okay, and and we want to do a very good analysis on this huge amount of data to understand if there are problems and issues like that. Okay, so that's one more area where then there is a utility sector, oil and gas industry. There are also huge amount of data is there. So I mean, what I want to tell you here is that wherever there is a huge amount of data, as we saw in the class 1, okay, MapReduce can be used to do the processing. Hadoop can be used to, I mean, HDFS can be used to do the data storage, and MapReduce will be used to do the processing. Okay, so let's take an example of one of these industries and look at one data set. Okay, let me show you something here. Now I'll also show you this data on from this place. Okay, so now this is the data. This is the data from a weather. This is the weather data of all the years. Okay, let me show it to you. Show this data right from this website. So you can also open it and you can see that whenever you get time. Let's look at one of the data sets. Let's look at the data sets here. Okay, so basically, if you look at this, right, there were huge number of files. Now this is one of the data sets, okay, which is which has an ID here. Okay, there's the station ID or something, and then this is the date, right? And then there is one column which shows the maximum temperature, one column which shows the minimum temperature. Let's see which one are those columns. Yeah. So basically, if you open this README file, I mean, I will send you the path to it. We'll be doing some exercises on this data itself. Okay. So if you look at this README file, which is there along with this data, it says this is the Weiban number, which is the basically identifier for the station on this, for where this data is taken. Then the columns are standard, the time here. Okay. LST underscore date. Then you have the longitude and the latitude here. Then there is the column number 39 to 45 is the daily max temperature, and there is the daily min temperature. Okay, so this is the README file which tells you how this data is formatted. Okay, now this is an unstructured file, log data. The formatting is here, shown here, and if you look at this data, this is how it is. So basically, I believe column number 39 will be somewhere, probably this one. This one is the maximum temperature. This is the minimum temperature. Okay, well we can figure that out. That's not the point here. The point is that this is the format in which you will have actual data in real life. There is an actual data set which we have taken from this website, and we'll see how to process this data fast. Okay, and what are the challenges in processing this data. Now, I mean, I'm sure a lot of you are from Unix background. Okay, and you would have seen and you've done some log processing earlier. So can someone tell me what was the way, if you had such a thing, and if I had asked you to tell me in this full file, find out the maximum of this row and minimum of this row. Okay, the maximum temperature and the minimum temperature. What would you have done? No problem. If you're in Windows background also, how would you process this? If you had this file, how would you do that? Will you write what program, what scripting language, what commands you'll use? From your background, whatever you would do, can you please tell me that? I want everyone to answer that. How will you handle such a situation if you had this? Okay, so I have a couple of answers. Vinayak tells me using grep. Dayanand tells me bubble sorting. And Vijay tells me in the Windows world there is a utility called log parser with which you can get all sort of metrics. Okay, and graphs. Okay, okay. What else? Anyone else who? I mean, I want everyone to actually think about this and answer it. It is very important. We cannot be only listening to this. Okay, so Jitendra, Amit, Abhishek, I want everyone. I mean, it's okay if you do not know the right answer. Okay, but okay, yeah, that's also one way. Put data in a temp table and find min and max. Yeah, right, Abhishek? I want everyone to answer, Vikas and everyone to actually answer this. At least think about it for a while. And then only we'll be able to appreciate the problem. So Narayan, Shyam, everyone, I want you to answer this, okay? Okay, so I have answers from almost everyone. That's very nice. So everyone has thought about it. Now, my question could be that, yes, so Satyam has given me a very good answer. We can even use Excel function max and min. Right, definitely. That's one way. Excel is a very good analytical tool. So definitely that is one way of doing it. Now, let me ask you another question now. So if I tell you that out of all these days, classify them as hot or cold days, depending upon if the temperature rises above 40 on a certain day, put it as max, and if the temperature goes below say 15, then put it as a cold day. Okay, if we had to do that. So similarly, some people are saying about SQL queries, yes. So it is not a very difficult problem to solve. It is a solved problem. So what is the problem then? I mean, it's not a very difficult thing to solve. If I had to do that, I'll probably write a awk program in Unix to do that. Okay, if people do not know about awk is a data parsing utility in Unix, and I think Vinayak must be knowing about it since he told me about grep. But anyways, there are multiple ways of yes, awk inside, right? So Vinayak, since you know about it, I want your homework will be to on this data set write a awk utility. Okay, write a awk script to actually send us back the results of on all the days, classify these days as good, hot or cold days. Okay, so that's something I want Vinayak you to do using awk. For the others, whoever has given this answer that how you're going to do on this data set, you should go and try that and send that answer back. I do not mind whatever way you use for that. Okay, is that fine with everyone? So whatever you've told me today that I'm going to do this, I want you to actually go back and try that out. Okay, so that you get a feel of how traditionally we were going to use it. Okay, is that fine, Abhishek, with you as well? And great, sure. So that's one thing which we want to do. Then only we'll be able to appreciate the problem. Now, so we've all of us have given some answer and all the answers were right. Okay, there was no wrong answer in this. So then what is the challenge? Can someone tell me what is the challenge here in this case? So you have a large data set, right? Great. So Satyam tells me if the data set becomes large, then Dayanand tells me, okay, Amit, what you have to do, let me just repeat that for you. The data set which I showed you, I want you to find the minimum and a maximum temperature on each day. Okay, and then classify that date as either a hot day or a cold day using a traditional way, whatever you would think of. Okay, size of the data, right? Now see, this is, so everyone understands that the challenge is not in processing this log. If this was say a few KB or a few MB log or even a few GB log, no one would have cared about it. You could have easily done that, right? Now the problem comes when this data set becomes huge. Okay, now think of it this way. Every day you have these things being stored for each across the world. Okay, so there will be huge amount of data, terabytes of data which will be there, and as we've seen earlier also, I mean it's very difficult to retrieve that data and do that thing, do the processing on that, right? So now one way of doing it traditionally was this, right? Now what this means is, if you have a very big data, split that data. This is the concept. Okay, split that data, do a grep. Grep is a command of in Unix to match regular expressions. Okay, so someone who doesn't know about that, don't worry, grep is a command to do that. Okay, you have a huge data set, process it in parallel, split this data, use grep, then look at the matches and then do a cat and finally get a result. Okay, so this will tell you this divides the huge data, then you take out the important data out of that, whatever you want to do that, whatever matches, you do a cat. Cat is a utility to combine all these things to get a result. Okay, so this is the way of doing it, right? So now even if the data set becomes large, you can use this, isn't it? So then what do you think could be the problem? If you had to write such a program which could do all these things on a large data set, you split that data set and then you do a grep. Assume that grep will solve your problem, then do a match and then do a cat. Can someone tell me what could be what is the problem in this scenario? Can you think about that? Or what are the challenges in writing such a program? Well, it will not take more time because you've anyway split the data, right, Vinayak? So even if it was 1 terabyte of data, you could have actually split this data into 1 GB, 100 or 1000 files of 1 GB, run it in parallel in different machines using grep, okay, and then do the matches and then do the cat. You can still store it in HDFS, right? On HDFS also you can run such commands, right? So tell me what is the challenge? I mean, if we know we can store it in a distributed fashion. Now, last time we had the challenge of when we did that exercise of number of minutes, the challenge was how long will it take to read the data. Okay, Amit is telling me splitting of data. Okay, so what is the challenge, Amit, you see with splitting of data? Jitendra, Rahul, Satyam, Vijay, everyone, I want everyone to think about this. Okay, great. So Vijay has given me a very good answer. You need to control this break and compute yourself. Well, data is unstructured, it doesn't matter, right? I mean, you can, it is because data is unstructured, that's not a challenge because, I mean, even that data which we just saw, the weather data, is anyways huge in size, right? You can divide that, you can vertically split it. That vertically split means row-wise split. FES, very good, Vijay. So consolidation is on you, right? That's one. Anyone else who can think about it? Think about some other, see this class, I want you guys to think a lot, okay, because it's very important to understand the challenges which are here. Then only you'll be able to appreciate why we need MapReduce, because MapReduce programs are very small. Okay, you will not find any challenge in writing a MapReduce program. No problem. Okay, Vikas is telling me processing of the huge data will take time. So yes, this is the very big data. I split that data, okay, into say 1000 parts. Now I am doing this in parallel, right? This is the solution I am proposing, right? This is the solution I am proposing to handle that large time problem, right? Now if I split and do it in parallel, then the time is not a constraint, right? Right, Vikas? So then what are the problems and what are the challenges? What solution do you need? For that is one thing. Okay, very nice. Very nice. Abhishek has given me an answer where he says managing 1000 individual units, individual parts manually is an issue, right? So Abhishek, we can write a program to manage that, right? Yes, definitely it is an issue. So you will not be doing that manually. You will be writing a program to manage that, right? Now let's assume we will be writing such a program, right? So what will be what are the things which we have to take care in that program? We are all coming to the answer. I know everyone is understanding that answer. Okay, so multiprocessor cost, no, that's not the challenge. That could be a challenge, but not really the biggest challenge. Abhishek, I know you have understood that, and what issue you were talking about, right? I want you to actually list down those issues. So Abhishek told me, and Vijay also actually told me that managing these 1000 jobs, right, or parts is a challenge, right? So you have to look at the scheduling of these jobs. That's a challenge, isn't it, guys? How do you schedule all these jobs? Great. Then the other thing will be some machines will be fast, some will be slow. Okay. Some will be fast, some will be slow. Some machines break down. Yeah, Rahul, very nice. So if some machine breaks down, then you have to solve that problem as well. Your program should solve that problem as well, right? Then there is a problem like if some machine is fast and some is slow, you may say, for example, you got a very slow machine here, okay, and this got into the critical path. Everyone understands what is a critical path? Everyone understands what's a critical path? Yes, or if someone doesn't understand, I'll probably explain it, otherwise I'll go ahead. Okay, looks like everyone understands. Okay, Rahul, sure. So critical path means that if your job takes, I mean, say multiple parallel paths, okay, whatever path takes the longest time, okay, will become your critical path in very, very simple terms. Okay, so that path will be very, say for example, if this path takes the longest time, and if there is a dependency obviously on this match as well to get the final result, then your job, even if these things are very fast, they'll have to wait till this completes. Okay, so this becomes a critical path. Okay, so that is something which you have to manage, right? So that is one thing which you have to manage. Then there has to be a big program which will take care of all these consolidating, scheduling of jobs, managing failures, okay, and then finally doing the consolidation, making sure all the jobs are completed in time. So those are the challenges which you will face with this, right? I am sure some of you will be able to write such a program as well to manage that, right? Who are the people who are confident that they can write such a program or have done something like this before? Anyone who has done that? Okay, Abhishek says not me. Anyone else who has attempted something like this or had such a problem in their regular work where they had to manage a huge log and they had to do something? Okay, but you can very well understand that these problems, if they are not occurring in your life today, they will occur in your life going forward, because now every company wants to do analytics. Earlier people were fine without doing analytics. They were just dumping the data, storing it for some time, and then keeping backups, not doing anything with that data, right? That was the traditional way of looking at things. Now people have started looking at that data as very, very useful information. They want to do a lot of analytics over that and figure out how to go forward in their businesses, right? So those are things which we saw in the first place. So even if you've not faced this challenge till now, I'm sure everyone in next 1 or 2 years is going to face this challenge. Okay, so and as we saw, it looks like a humongous task to actually write such a program which can take care of all these things and make sure that the system still runs properly. Okay, so that is where now you can appreciate the problem which we are facing, right? So that is where MapReduce comes handy, and that's where MapReduce comes into picture. So what does MapReduce do? What is so great about MapReduce? Now, before going there, I also want to understand what are the bigger challenges, right? One big challenge which I want everyone to appreciate and understand is that it is not only splitting this data in parallel, okay, and doing the processing. There's one more thing, which is the movement of data from the data store or your database to the place where the processing is going to happen, right? That data movement is also a big challenge, right? And it takes a lot of bandwidth, right? So does everyone understand this? I mean, is that something which is very clear to everyone? I want an answer on that from everyone. Great, thank you, very nice. So now, okay, yeah, Amit, I was telling that you have a data stored somewhere, okay. Now there is a processing unit where the processing happens on that data, okay. Movement of data from that store to the processing unit, right, takes a lot of time, right? Yes. So Vijay is saying to help that, move the computation to the data store, right? and then we need to move back also, right? True. So basically think of it this way, that you had say a few terabytes of data stored somewhere, and you wanted to do some grep over it, match some patterns. Say for example, you wanted to find out, so there was actually, I'll tell you a real life example. There was a DOS attack on Network Solutions yesterday, and Edureka's website went down, okay, because of that. Now, how would you handle such a situation? You will have huge server logs. You'll probably try to find out the IP addresses which were doing some suspicious activity, right? So those logs would run into terabytes, and you have to do that very fast, because you have to actually find out the solution very fast. You cannot wait for days, right? Otherwise, lots of businesses will go down, right? So if you have to move all that data, terabytes of data, to a processing unit and do the processing at that point, the challenge will be not only doing that thing in parallel. I mean, you can always split this, but if you could get this computation at this point itself, right? This computation, if you could move at this point, or some part of this computation to this point, it would really help. Okay, so this is what I want to tell you. So two challenges in a traditional way of solving problems. One, we cannot do it in parallel. Running those jobs and scheduling those jobs and understanding them, doing them together is one challenge. Second challenge is that the computation, movement of data is even a bigger challenge. And it is very difficult to understand looking at, when we do a MapReduce program, that this is the bigger challenge, because you'll be doing it in a small set and you'll be able to quickly do things, right? So now that is what I wanted to bring to your notice. Okay, so let's see what is MapReduce and what is the MapReduce process. So those are the two things. We'll come back to those two things again. But before that, let's try to understand with this example that how does actually MapReduce work. Okay, so very similar to the earlier problem, there is one thing which we do in MapReduce, and I'll explain this very quickly here. I'll come back to this example again and again. Just want to make sure that this gets into your mind very clearly. So let's think of it this way, that we have an input which is in this format. So we have a deer, bear, river, car, river, deer, car, bear. Okay, so these are the examples which we have. Now, and this could run in huge amounts, right? What I've done here is I split this data. Okay. Now we'll look at how one thing which you should keep in your mind is, how is this splitting done? What are the challenges there? Okay. What are the considerations while we split that data vertically? Okay, those are the things we will just discuss in a while. So do not think about them right now. But splitting is a challenge. Just that you need to understand. Now, when we split them, you get such records. Okay. We need to, so MapReduce consists of two parts largely. Okay, the mapping part and the reducing part. And what we wanted to do in this particular thing was, we wanted to understand that in this huge data, okay, how many occurrences of bear, car, deer and river happen in this huge data. Okay, now you can correlate this as the other thing also which I told you, how many times a particular IP address came on a server log. Okay, so that could be also one of the things which you could be doing using this method only. Is that fine? Does that correlation make sense to everyone quickly? Yes or no? Great, thank you. Now what I'm trying to tell you here is that Rahul is asking me, please explain shuffling, didn't understand how similar occurrences are clubbed together. It is done by us, so if so, how do we do it? Rahul, I have not explained it yet, yaar. Don't jump the gun, just wait for some time. I assure you by the end of this class, okay, and this time it will not be 4 hours, it will be lesser than that. You will become an expert in understanding MapReduce. You will become an expert in writing MapReduce programs after this week, once you do all the practicals. Okay, just wait for some time. Let me complete this. Okay, now we appreciate the problem, we understand the problem we are facing, right? The problem is the challenge is that we have this kind of situation where we have huge number of occurrences of some particular thing, and I want to split it. First challenge is splitting. How do we split? Where do we split? What would be the split boundary? I'll explain in a while. Second thing which we do is doing a mapping. So the map process is actually creating a list of key value pairs. So this was a key value pair. Okay, so these were key values, and here we will be creating a key value pairs. So what I did is, at every occurrence of deer, I made it 1. Okay. So I created a value associated with that. Similarly, on every occurrence of bear, where I wrote 1 against it. I wrote 1 against the river. In this example, it will be car 1, and river 1. I'm not doing any consolidation here. I'm not saying car 2. Okay. I'm not saying that right now. Okay. So in the mapping part, what you do is just pick each of these data sets, data points, okay, keys, and create a value against them. Okay. So that's what I've done in this. Till this point, everyone is clear how we are going to do this? For each of these occurrence, add a value here. Okay. Right? Is that fine? Everyone is okay with this part? Should the value be same? Yes, the value, you mean to say car 1? Yes. Value depends upon whenever you find something, some occurrence of a word, you write 1 against it for each of the occurrences. So car came once 1 came here. Car came another time, another car 1 came here. Okay. We are not saying car 2 here. Okay. That will be something which we'll be doing later. For now, for each occurrence, independent of the other data, that's why you can do it in very fast, right? You don't have to do any logic here. Whenever you find something, add a key value here. Okay. In the next step, what we try to do is, we try to consolidate these things together and try to shuffle them. This is called the shuffling and the sorting part, where similar keys are sorted and kept together. So bear came here, bear 1 came here, car 1 came here, deer came here, river came here. Okay. So this is called the sorting and the shuffling process. Okay. Right? Is that fine with everyone? And then finally, this is the reducing process where we actually write a function. It could be a max, it could be the actual processing, the actual calculations happen in this reducing step. Okay. Where we actually, here in this case, we are doing a summation, right? Correct? So we are doing a summation here. So this came as 2, this came as 3, this came as 3, 2, and this came as. Finally, you consolidate all these, and this is your final result. Okay. So this is clear to everyone. We create a list of key value pairs in the mapping state, just a list of key value pairs. Then what you do, after shuffling, you create a key and a list of values. So basically key is this, bear, and list of values. So let me explain that on Notepad as well, how it will actually look like. Okay. Let's see. So basically, if you had, the first step will be giving you deer 1, sorry, deer. Deer 1. Okay. Let's assume that we had, instead of bear, we have beer. Okay. So beer 1, beer 2, and I want to calculate how many beer I need to. Yes, Abhishek, that's what I'm trying to explain. So Abhishek is asking me, what is the significance of K1, K2, K3? Right. So that's what I'm trying to explain with this example. Okay. Now, the first thing which I do was this, right? That is where so initially there was K1, V1 was basically, you're not able to see the notepad. Why is that? Well, can you see it now? Is everyone able to see it now, guys? Notepad? Okay. Okay. So, wait a sec. I lost it again. Yeah. So basically, initially what we had was data like this. Or whatever, right? We had a lot of data like this, river. In each split, we had something like this. Okay. So in each split, we had data like this, right? Is that fine? Everyone is able to see that? Okay, good. Then what we did was, for each occurrence of deer, I created something like this. Whenever deer came in, say if deer came here as well, for I started processing this file and I did deer beer1. Sorry, I'm sorry for the spelling, the mistakes here. So this way what you can do is you can keep on processing it without worrying about any logic that how many times deer came in, right? I'm just doing this part here. I've split, right? Then car, whenever car comes, I create a key value here. Now ideally, when you would write such a program to do this processing, what would you do? You'll write a program, you'll keep a counter for every word. Whenever that word comes again, you increment that counter, right? That's what you'll do, right? Isn't it? But we are not doing that here, and there is a reason for that. Okay. The MapReduce programming model divides these two parts. Okay. So first thing what we do is that instead of doing that, all that processing there, we do processing in parallel, and irrespective, and you'll be able to appreciate it once we go a little further. For now, just try to understand how we are doing it. So instead of keeping account of what was there earlier, I'm not doing that. I'm just whenever I get an occurrence, I'm just creating a key value here. Okay. So this is the key value K2V2. Okay. Here. Okay. And then what I do after that is that once I've got this, then I'll do a shuffling and the sorting, and what I'll do is I'll create something like this. Deer 1 1. Okay. Bear 1. Car 1. And river 1 1. Okay. So basically the next step after shuffling and sorting, I get something like this. So what is this? This is a key and then a list of values. Right? Is that clear? This step? Why do we say key and a list of values here? Everyone is clear on that? Right? So this is a key and a list of values. Okay, Abhishek is not clear. Okay, let me explain that once again. Now, this is a list of key and value. Is that clear to everyone? This is a list of key and value, this part, Abhishek. After shuffling and sorting, what we create is a key and a list of values. For each key, there is a list and value. Forget about this K2V2. Let's keep it simple. Okay, let's try to first understand it, and then I'll tell you why we do that. Now, this part is what is this? A key and a value list for each key. What I've done is just consolidate them, not even added them yet. Now, is this clear, Vijay? Abhishek? Great, very nice. Then the next step is where you do a K and some function on the list V. Okay, so this is the step which is called reduce. Okay. Now what this function is, it could be anything. This is your actual function. Okay. This function in this case is summation. So what you did, if this function was sum, then what you get is deer 2 and bear 1, car 1, river 2, right? This is what you get on this, applying this function, right? Finally, what we get out of this is another list of key and value. Hey, is this a list of key and value, right? Is everyone clear? Shyam, I'll just answer your question. Just give me 1 second. I want to understand if everyone is clear with this step. So on this key value, on this output, right? On this output, I'll apply a function on this list V of these keys for each of these keys. If this function is, say, and what will I finally get? I'll get a list of key and values again, right? And finally, I'll get this output. So each of this is a list. In fact, if you look at it this way, this is a list. That's the more perfect way of saying this. Abhishek, is this clear to you? Are you writing something? Vikas, Vijay, Satyam, or is it a little confusing right now? Great, very nice. Okay, great. So everyone is saying absolutely clear. So I am assuming that everyone is clear with that. Shyam had a question which I'll just take up right now. So Shyam told me the shuffling should be same in the diagram what you're showing in Notepad. Yes. So in the diagram also, I mean, it's not very different. It's just representation. Okay. Bear one together will become this, right? Instead of deer, I've put this. Right. I just wanted to make sure that this denomination of list is clear to everyone. Is that fine, Shyam? Shyam? Narayan, are you still able to follow me? Great. Amit is not able to follow. Now, Amit, where did you get lost? Where did you lose the thing? Okay. So basically, we had initially, what did we have? We had this kind of, forget about this part, let me delete this. You had this kind of input. Okay. Now you split this into key and values. Okay. So you got something like this. After splitting, you got something like this. Then after splitting, you did, this is the mapping process. Okay. In this mapping process, wherever you saw some occurrence, you kept on adding this. So what you got was a list of key and values, right? Okay. Now, next step, what you did was after mapping, you did a shuffling and sorting and you got all these together. So this is the shuffling and sorting process. Okay. So what you got was a list of key and a list of values. I mean, so basically this whole is a list. This is the key and this is the list of values, right? Very similar to what we got here in the diagram, right? Bear, you can also represent this as bear 1, 1. No, see, key is, deer is key. This is one value. This is one value. This together is a list of values. Okay, fine. Great. Then in the next step, what we got, now we have to process. Now the actual thing comes. Whatever we want to do, if we want to do a sum here, we write a function. Okay, so this function in this case, wherever we do this function thing will be the reduce step. Okay, in this case we had to do the sum. So finally on this list, whatever we had, if we do this, what we get is another list which will have deer as 2, bear as 1, car as 1, and river as 2. Right? So this is the reduce step. Right? So all the steps are clear now, guys. Can I quickly get a yes from everyone? We'll get more clarity on this. We'll see a program also in Java, how to do that. Very nice. Very good. Thank you very much. Great. So Narayan, are you still there? Are you able to follow this from your mobile? Vikas, is it clear to you as well? Yeah, Vikas has already responded back. Thank you very much. Great. So now let me just save this as some example. Okay. Now, yes, splitting is divided the input file into blocks. I will send you this file. Sure, I will send you this file. No problem, Amit. I'll send you the file to everyone. Just ask the support team, they'll send it across. Okay. Sure. Now, don't worry about the splitting part right now. Okay. I'll be explaining that. Yes. Yes, Amit. Please tell me. Amit, all these questions you can ask from the support team, or you can send me an email regarding the video recording and all those things. Okay. You can talk to me offline about this here. Okay. You can send me an email at abhishek@edureka.in. I'll respond there. Okay. Let's not talk about this in the class. Okay. So now let's go ahead and let's see. So everyone has understood at a concept level that how have we divided the processing into two parts, the mapping part, the shuffling part, and the reducing part. Let's see what are the advantages and what are we actually doing. So same thing in a definition side of things. MapReduce is all about key and values. In the map part, what we do is this key value to list of key value, which that is what we just saw. In the reduce part, we take this part and create a list of this by doing a function on this. This slide is clear to everyone? This is the map process, this is the reduce process. Can I quickly get a yes on this, if this is clear? Very good, thank you. Now, so basically what we've done, again the same thing comes in. Okay, the same diagram which we drew earlier, right? With the grep and the cat thing, the MapReduce framework takes care of the whole thing. Okay, so very big data, the splits have to be handled here. So this boundary shows you the MapReduce framework. All those things which you had to think of is being taken care by the MapReduce framework. The map part happens, the partitioning function happens. We'll talk about partitioning also, and the reduce part happens, and finally you get the result. So your big data, how to split and all those things, you don't have to worry about it. The MapReduce function takes care of that. How to schedule the jobs, how to run the jobs, the job tracker and the task tracker will take care of that, right? You remember job tracker and the task tracker, right? Everyone remembers about them? No one has responded, so no one remembers about it. Okay, so basically, yeah, thank you. So great. So now in this case, what will happen is the job tracker will take care of the fact that where all do I need to run these maps? Okay, where all do I need to, how do I split the data? Where all do I need to run the maps? Okay, how to get that data back? If the machine fails, you have to get that output back, right? We have to make sure that another machine is used there. Okay, so all those things are taken care by the MapReduce framework or the Hadoop itself. To put it simply, Hadoop will take care of that. You just have to implement your map function and your reduce function. Okay, is that fine? So life becomes much more simple. Now everyone who was telling me that I will not be able to do something like this becomes very easy, right? You just have to write a map function for yourself and a reduce function for yourself, right? Isn't it, guys? So Abhishek, Vikas, all those people, Vijay, who told me I cannot do this, now now Hadoop has equipped you also to do this without worrying out too many things about how the processes work and how things are being run, right? Vinayak, we'll come to that. Okay, just give me some time. I'll explain that as well, where the shuffling happens. Okay. So now, before we go there, guys, I just want a small break if you don't mind. I'll just be back. You keep looking at this diagram, okay, and try to understand what is happening here. I'll just take a 5-minute break, okay? I'll come and explain this once I'm back. Okay, is that fine, everyone? Just take a 5-minute break, think about whatever we have done till now, and look at this diagram and try to understand that. I'll be back exactly in 5 minutes. Okay, thanks. Am I audible now? Am I audible now, guys? Okay, great. Okay, so basically we'll just try to understand this once, and then we will move on to Java, and we'll see these programs being written in Java. Okay, so let me tell you, Abhishek, I'll just answer your question in a while. Okay, for whatever you've asked, I'll tell you just a minute. Okay. Okay. Now, see, one thing which we need to understand, what we initially talked about this, right? We talked about the fact that we have to, one of the biggest advantages of MapReduce is that you take the processing to the data, right? Not the other way around, right? So how do we achieve that? What we do is that we run a map job. Okay, map job will be run by a task tracker on the data node. Okay, on one, say based on, let me just open the notepad once again. Okay, so now, so for example, this is, say for example, if this is the data block on which you were running your job, on which you had to do some processing, right? If this was the data, right? And also need to understand that this is one of the split of the data. Okay, so first thing, we have not yet discussed about how to create a split, but just assume that there is a split of data on which I'll be running a map job. Okay, so this is one block of data on which I'll be running, this is the map job. Okay, now the best case will be that if I was able to run the map job, and these are all data nodes. Now this diagram shows you different racks, and these are different data nodes. Okay, so this is the representation, and this is the block of the data, and this is the map task which we will be running on this block of data. Is this much clear to everyone? That these are all data nodes, this is a rack, and this is the complete cluster, and this is the block of data on which we will be running, right? Yeah, sorry, yeah, blue is the block, yes, sorry, yes, that's right. So blue is the block, and this is the map. Okay, this is the map task. Now in the last, yes, that's right, I'm sorry about that. Okay, so actually it doesn't really matter much. Okay, both ways I can explain, both ways will look symmetrical to you. Okay, either way it will be fine. Let me explain that. Now what you have to do is that you have to make sure that and you also remember that there can be multiple blocks in a data node, right? Huge number of blocks can be there on a data node. 64 MB is generally a block size, right? Great. You also know that you can run limited number of map tasks on a data node. You remember we set that parameter number of map tasks in the MapRed file. Does everyone remember that? Last time when I told you that we will be discussing more about it in the next class, in the configuration file of mapred.xml, there was a parameter which said that how many map tasks can be run on a data node, right? Yes. So basically, Rahul, just a second, that will become very clear. Okay. Now, the thing is that there can be multiple blocks, okay, but on a machine, you can only run certain number of map tasks, right? Because it's a processing thing, and there will be, but we need the based on the number of splits we have, that many number of map tasks we need. Okay, right? So basically, based on number of splits, we need the number of map tasks. Okay, so if you have 1000 splits, you will need 1000 map tasks to be run. Okay, on a machine, it is not necessary that all 1000 can run on the same map task. Okay, best case will be this, where you can run the map task on the same data node. Okay, so if this is the map task, it can be run on the same data node. Okay, so data flows from this to map task. Okay, and you run the map here on the same machine. Abhishek, is your question answered now? This data is flowing from this to map task. Abhishek, why the arrows are pointing this way? It shows the data flow. Okay, great. So this is the best case scenario where you don't have to transfer data between any machines. Now there is a possibility that the number of map tasks running on this machine are already running, okay, and we have to run a new map task, and the data is on this machine, but the map task cannot be run on this machine. What will you do? You'll identify the nearest machine in your same rack on which I can run a map task. Okay, so this is that scenario. Here the data transfer will happen between data nodes. Vijay is asking, can more than one same map job run on one node? What do you mean by same map? I'm sorry. What do you mean by same map job? Yes, same node, multiple map jobs can be run. You want to speak? Shall I unmute you if you want to ask something here? Okay. Now, while you type, I'll just explain the other worst case scenario. In the worst case, what will happen is all the map tasks which can be run on all these data nodes are all still running, and you have something to do. In that case, what you will find to do is you'll try to find a data node on, or a task tracker to be exact, which will obviously be running on a data node in a different track which is nearest to this. So in this case, there will be a data transfer between rack to rack. Data transfer has to happen. Okay, right? Yes, in example B, map task is running on a different. In this example, see, this was the best case scenario. No, Abhishek. Let me explain you. So the best case scenario is that you don't have to move any data. Okay, minimum data movement is what we want to do. Taking processing to the data. In actual world, in the traditional way, what you would have done is your processing would be happening somewhere here. You would have taken all this data and got it here and done the processing. What we do here is the map is moved to the data node itself. So if the data node is, if the map task is available here, we'll try to do this here itself. Okay, this is the best case scenario. Okay. In case the number of maps running on this are already exhausted and you cannot run a map, then you will not wait, because that will be a long time, right? You will not wait. You will try to find the nearest nearest place available where I can run the map job. So you'll move the data from that place to this place in the same rack. Okay. So this is the second best scenario, not as good as this one, right? In the worst case, what will happen is all the maps which can be run on this rack are running and they're busy. Okay, in that case, what you will do is you'll find the next possible data node on a different rack where a map job can be run, and you move this data to that place, right? Best case will be this, then this. In the worst case, this is the scenario, right? But it is still better than taking this whole data and taking to a processing unit, right? Is this clear to everyone? Abhishek, is your question answered now? Okay, wait. Guys, there's no replication factor here. Don't get confused with that. These are two different blocks. It doesn't matter. Don't get replication diagram here. Okay. This is some block of data. A, B, C are different blocks of data in different scenarios. A is one block of data. I want to run a map task to do some work here. So I did it here. Ideal situation will be that the map task run on the same data node where the data resides. That is the ideal situation. But we do not get an ideal situation all the time. So this number of maps on which can be run on this data node may get exhausted. They may be busy. So what we do in that case is we move this data to the nearest machine where I can run a map task. Okay. So this could be the machine. Now this diagram has been taken from Tom White's definitive guide. Very good explanation. I want everyone to actually follow that book as well. Okay. So now basically see, now this data is moved to this place. Okay. Abhishek, the book name is Definitive Guide. Okay. I'll send that across. This is the second best scenario. Okay. Now once if we are not able to find a map task which can be run on the same data node, we run it on a different data node which is the nearest. Okay. In the worst case, if all these get busy, then we'll run it on a different rack, and then the data movement will happen. Is that fine, Amit? Amit, is your question answered now? Vijay, yes. So basically on each block of data which you want to process, okay, you will have to run one single map job. Okay. Okay. See, whether it is replicated block or not, there also the same thing will happen, right? You will be doing the replicate on, if we do not find the data here, you will go to the replicated block also, right? So don't confuse this with the replication. Whenever you have to do a processing on some data, this is the process. Yes, Dayanand. Okay, so Amit, yes, Amit, basically, see, that is what we are doing. Map task will be run on the data node. Now, if the map task is not available, if it cannot be run on that data node, see, there are limited number of map tasks which can be run on data node. This is configured by the user, depending on the machine processing as well, right? So basically, but there can be huge number of blocks, right? So in the best case, this is going to happen. The same on the same data node, you will be moving that. In the Vijay, just a second. And in the case when that is not possible, you will actually be running it on a different machine which is nearest. So this much data movement has to happen there in that case. In the worst case, in this situation, the map job will be running here. So in that situation, a little bit more data has to happen. Okay. Is that clear, Amit, now? Vijay, I'll just answer your question after this. Let me clarify if Amit is clear now. Okay, great. Thanks, Amit. Now, Vijay, in this case, is there a limitation on number of job maps running on a node? Yes, there is a limitation. Now, depending upon your machine and everything, right, you decide that. We set it up, right, in the MapRed XML file that you can run only these many, because these will be parallel jobs which will be running, right? So based on your machine processing and all, we'll decide that. So basically, okay, so right, so if the map jobs are not available, you will move to a different machine. Okay, so is this clear to everyone now? So if you have to run two parallel things on the same data, then two map jobs will be required for that. Okay, Vijay? No, okay. So Shyam, the map will be running on a different node, okay, in a different rack. The data will be moved from this data node to this place where the map is running. Map is not moving. Map is still running on the place where it is available, right? See, in this case, map is available here, so it is running here. In this case, this map was not available, so it ran here. Okay. Then in this case, we move the data. Okay. Now, in this case, the map is available. The map is available here, so we had to move this data to this place to run that job. Okay. Does that answer your question, Shyam? Vijay, I'm just reading out your question. Just give me a while. Shyam, is that? Should we not move data to another data node in the same rack and then move the map also in this? So, Abhishek, the reason why we moved in a different rack was that no map could be run on this whole thing. If there is not a possibility of all these maps in this data node are busy, then only we'll go to the next rack, right? Otherwise, we'll do the same thing which you're saying. The map can say, if in this case, this map is not available, this map is available, I'll run this map here, I'll move this data from this point to this point, right? This scenario is not very common. And as a user, you are transparent to it. Hadoop will be taking care of that. Well, Shyam, the data movement is temporary. Okay. So you don't have to worry about that part. Okay, no metadata thing. The data still remains here. Amit, the problem is that data, how will you move the map? Map can be run only on this. If say there is no slot available to run a map, what will you do? Data only has to move to the place where the map can be run. Best case is the map can be run on the same machine, you will run on the same machine. If it cannot be run on the same machine, then you will run on the different data node on the same machine. If it cannot be done there as well, then you will be running it on a different rack, because this is where you will find, and you will move the data. Vinayak, yes, that will be done, but if what happens if the replica also faces the same problem? Let's not worry about the replica. Let's assume that the replica is one only. Okay, then this is the scenario. If the replica is 3, 5, such scenarios can still occur there as well, right? Amit, is that clear now? Vinayak, is your question answered? This is a very important concept to understand, so please keep asking questions. Great. So, Amit, are you clear on this? Okay. Yeah, please then write your question. Vijay, after all these questions are clarified, I'll take up your question and answer that. Okay. What if a rack is busy, then it will wait. See, though that is the situation where nothing, if no map is available throughout the cluster to run, then you'll have to wait. It will take more time. Now these are all things which are done to optimize things, to make the processing more efficient, right? If this was not allowed, then you will keep on waiting till this map gets free, right? So since we know we can leverage another map on a data node, if we move this data here, right? And you do it quickly. If we know that no map is available here, you look at this place in a different track. If no map is available on any data node in the cluster, then you will have to wait, obviously. Okay. Fine, Vinayak. So I think I've answered all the questions. Everyone is clear with this? Abhishek, I want everyone to confirm that this part is clear. I'm sure there will be a lot of questions which you'll have in mind, but please make sure that fundamentally this part is clear, right? And we can keep asking questions on this. We can spend 2-3 days on this. So copy of this will be moved here, Dayanand. Vijay, I've not reached the reduce part, so I'll answer that question. Okay. Okay. So everyone, I believe, is clear. Okay. Good. Now, yes, exactly, Vijay. Yes, that's right. See, this is just for representation purpose to understand that what are the challenges, and we are taking the processing to the data, right? Now, this is only the map task. Once the map task is done, whatever comes out of the map task, the key value pairs, then the reduce task will be run. Reduce task will also be run on one of these machines only, right? So you'll have to identify where this will be run, and there that part will be moved, and there will be the reduced job will be run there. Okay, is that fine? Is that fine with everyone? So basically the map task will take out most of the things from the data. You get just only a small part of the data now, which will have to run in the reduced job. And that reduced job will also be running on one of these machines only. Okay, it could be here, it could be here also, it could be here, anywhere. Right? But say there are 5 map jobs which are run all over here, and a reduced job which runs here. Right? Fine. But we'll come to that in a while. Before that, let me show you, let me just go a little back. See, in this slide, I just want you to understand that the advantage is taking the processing to the data and not the other way around, and what are the different scenarios in which we can run a map job. If this much is clear, we can stop here. We need not think more about it right now. I am sure all your questions will be answered in a while before we end the class. right? If this much is clear. And also the part that data processing happens in parallel in a MapReduce framework. Can I get a quick yes if this much is clear to everyone? Very nice, thank you. So now let's do small. Let's do a small. Let's see a small program. The same program which was there. Let's see it in Java now. Okay, which we saw the dare bear example, the count example, and also the data set example which we had, weather data set. Let's see an example there, and let me show you how it looks like in a in an Eclipse environment. Okay, everyone is familiar with Java. If not, it's not all that difficult. I mean, you have to go through those basic programs. Yeah. So let's first get started with our program, okay, which we wrote in the bear dare example. Okay, so it's very similar to that only. Okay, now what do we have here? We have a class called map, okay, which extends the MapReduce base class, okay, and implements the mapper interface, right, which has long write text, and int write as input outputs. Okay, now then we have a function or a method called map, okay, which we are overriding. Okay, so this has the key and value inputs, then the outputs, output collector, okay, and then a reporter which will be reporting, doing the reporting. No need to worry about it right now. Okay, and then here, and it throws a IO exception. Okay, so this is the IO exception. So what do we, yeah. Okay, so basically these are the say values here, right? Now if this is what you had, if this was a record, okay, value was a record in this case, right? So what we do is we change it to a string. Okay, so what will that do? Can someone tell me what will this function do? Value to string. Yeah, convert it into string. So text type is a Hadoop data type, okay, and you convert it into string. So what you get here is there were river in string as a string, and then what you do is the next line string tokenizer new string tokenizer line. So you pass it on to a new string tokenizer. Okay. So what will this do? Can someone tell me what will this do for the benefits of all the people who are in the class? No one knows about this? Okay, so this whole line will be divided into tokens, exactly, right. So basically it will be divided into tokens. So for example, if you had say, I am fine, okay, this will be divided into I am fine. These will be all different tokens. Similarly, this will be divided into deer, bear and river, okay. So basically this will split the data into different tokens, okay, and we will store it in this tokenizer, okay. So this tokenizer will contain deer, bear and river as separate values. Okay, is that clear to everyone? Can I quickly get a yes from everyone? Very good. Then what does this part do? This part will say while tokenizer has more tokens. So you loop through this tokenizer, deer, bear, river. Whenever there is a next token in the output collect, what you do, you add the value int writable 1. So for each token, you say, for example, let's take this example. If you had this, I am fine. The output of this loop will be I1, am1, fine1, I1, am1, fine1. So this is what it will do, right? Okay, so this value will set the value, and the value will be, then we'll be writing what is there in the value. We'll write 1. There's no match condition here. Why do we need a match condition? Amit, why do we need a match condition? We are just doing, whenever I find something I'll write 1. No, we are not counting here, right? That's the thing which we saw earlier, right? In the map, we are not counting. We are just adding tokens, right? We are just adding value there. So the output is not I2, AM2, find 2. That's what the whole idea is. In the map program, remember that slide, right? This is what we are doing, right? Yeah, don't, and Mamit is actually reducing. Okay, got it. Now, okay, so this is the output of this guy. Okay, the shuffling is done automatically by Hadoop. The shuffling is done automatically by a Hadoop, and the output of shuffling will be something like this. Okay, so is that question answered? Rahul, you had a question where the shuffling is done, how it is done. So the output of this program, map program, only will be shuffling. Okay, now this input is going to go to the reduce. Let's see how does reduce looks like. So this is the reducer, right? Same thing. Extends the map reduce base, implements reducer interface. Okay, this is overrides the reduce method, throws IO exception. Here you do that summation and that all those things, right? While values has next. Now values, what does this values contain? Values contain something like this. Okay, while values has next, you write a sum, values next dot get. Let me just write it and to make it very clear. Okay, so does that make it clear? So what you get here is key and values, right? So I will be coming in here, I and values will be coming in here, right? And then you do a sum. Has next means has something. The values has something, right? Right, same thing. The same function was used there as well, right? And then what you do is values dot next dot get the value and add it to the sum function. So finally what you get, if this is the I and this is the value, if this is the key and this is the value, at the end of it you will get I5. Or if you had bear here and 111, you would have got bear 3. Is that clear to everyone, guys? And then finally you will be writing it into a list. So you'll create a key value list here. Everyone is clear with this program? Guys, I need an answer, yes or no. I'll wait for everyone to say yes. Good. I have got a smiley also today after a long, so Vinayak has given me a smiley. Thanks, Vinayak. You are really so kind of you. Okay. So the counting is happening here, right? Amit, you understood, right? So if you had to write without a map reduce, you would have done this thing right away. You would have done the parsing and you would have done the counting here itself. Now what we did was we divided this program into two parts. The parsing was done in the map, the counting was done here. Okay, so this is the way we divide into a map and a reduce task. Shuffling happens here itself automatically. You don't have to do anything here. Okay, so whole of this is clear to everyone, this thing, whatever we did here. So this part and this part is the output of the mapper. Okay, right? And then this is done. So these will go one by one. These will go one by one into the reduced job. Once this goes, then this goes, then this goes into the reduced job, then this goes into the reduced job. Okay, and then we get these, right? Is that clear, guys? So there can be a scenario where you do not need any reduced job. That's also possible. Only a mapper can do the trick for you, right? And there can be a scenario where you need lesser number of reduced jobs, right? So all those things exist. Is that fine, guys? Everyone is okay with this Java program? Now let's run this Java program. Okay, and let's run this Java program. Let's see how do we, so what do we have to do? First we have to create a Java archive for this, move this program to the HDFS, right? And run it there, right? So we'll do that process now. Now let's try to, before that, let's try to understand this main as well in this program. Okay. So what do we have? We set this map class. Okay. We create the job name here. Okay. Right. The job conf is the thing which we use for the word count class. Okay. Yes, Vijay, exactly. So each key is given to the reducer to sum from the iterator collection. Exactly. That's right. Right. Now set mapper class, you set the map class. Set reducer class, you see this class. Set output key class is being set. So basically what is the kind of output you have? You have text.class and output value class is int writable, right? Okay. Input format is text input format, output for text output format, right? Don't have to worry too much about it. One thing which is very important here is this. Okay. File input format, the input of this program will be the input path where your data will be kept. Was from where this should pick the data. Okay, the path of that place in the HDFS. And you also have to specify the file output path which will be taken from arg0 and arg1. Everyone understand what is arg0 and arg1? Can you tell me that? So basically this will be the inputs which will come to this main program when we run this program, right? Everyone is clear with this now? And then we finally run this job. So these are the two inputs, command line arguments, right? So these are the two inputs which will go into this program, right? Now let's create a Java archive for that, and I'll send you the process. Separately it will be there. We have created a small video also, but let me create that Java archive file and move it to the HDFS, right? Let's see it. Okay, so let's see how it works on the VM. Everyone is familiar with our VM. Last time we ran a few programs, the Terragen program, which was not our program, that was Cloudera's program. This time we are going to run our own program. Okay? Amit, what do you want me to explain? Yeah, just a minute, Amit, I'll explain that once again. Okay, just hold on for a second. So now see, this is the IP address of the VM on which I'm running the thing, right? So what I'm doing is the jar file I've created. I'll show you how to create that in a while, but just assume that I've created a jar file. Here I'm moving this to doing FTP into my Cloudera VM, right? Connected it to the client on this IP address. Okay, can I quickly get OKs from everyone if you're understanding this process? Then just keep writing yes. Okay, so let's move this our program. Let's first create a jar out of this. Yeah, we export, type jar, right? Give a name to it and a path to it. Right, so this is where we'll keep it. So this will create a jar file. We'll create we'll have to specify the main class name. The main class name is word count. We're done. And then we say OK. Okay, it gave some warning, but that's fine. So this has created a jar file. Let's see where the jar file is there. So we got this Java archive file, right? Can I quickly get that okay on that process? Everyone knows how to create a jar file now? Okay, good. If you do not know, if you are not very familiar with Java, don't worry about it. You can easily understand it. There's no challenge there. Now we moved that jar file from our local machine to the Cloudera VM, right? And we do a ls, we see it here, right? Is that fine, everyone? The same jar which we created. Right, good. Now, let's see the data on which we are going to, yeah. So basically it will depend upon your internet speed and a little bit upon our internet speed as well. So let me explain that process once again. I created a jar file, Abhishek. Then I moved that jar file from my local machine to the Cloudera VM, the place where it was running. Okay, so I just did a ls and saw that file was found here. This much is clear, everyone? Can I get a yes from everyone? Abhishek, you also are clear on this? Amit, Abhishek, Rahul, Vijay. Okay, a lot of questions are coming in. Let me read out the questions. So Vinayak, we moved it to, by default it will move to the home directory. Okay. How to create jar? Yeah. So jar is a simple thing to create in Unix, in Java. Okay, using Eclipse, we use the export command, created a jar, specified the main class, and then a jar was created. If you don't know that, I believe you need to do some work on Java, but don't worry. We'll send you a small video which will show you how to create the jar file. Okay, Amit? Right. Yes, home directory, not of the name node. It will go into the master only, but not in the. This is not HDFS. This is my local file system, right? I'll move it to HDFS as well. Okay, wait. So this program. Okay, so now this is the data which I have, right, in my local. No, there is no space. You can keep it anywhere, yeah. Okay, it can be kept anywhere. Okay, so now this is the data on which we want to run. Okay. Now this was the data on which we want to run our MapReduce program. Okay, so let's move this data. Now what we've done is this data is available in the HDFS. So this is the data which is there on the data node, for example, right? Now earlier we saw that data was there. Let me delete this data. Okay, now we've deleted this. Now this data is not here. What I'll do is I'll move this data which we saw from the local to HDFS, right? Using the put command, right? And there can be many ways of moving data. This is one. You can move data in many ways, right? And this is where I move that data, right? Now let's see if this data is there. So we got this data here, right? Everyone is clear with this? Now this data is the same data as we saw earlier. So on this data we are going to run that program. So this is the data and this is the same data, right? Everyone is fine with this? Guys? Yes or no? Can I quickly get a yes from everyone? Great. Now let's run that program and see what is the output. And see how do we run that program. So you remember this command Hadoop jar, last time we ran it on the Cloudera programs. So this is our jar now, right? What are the arguments of this? We have to specify the input directory where the data is found and also the output directory where you want to put the results, right? Yes or no? Quickly, yes or no? So those are the arg0 and arg1, right? Let's do that. Okay, so let's run this program and see what happens. So it is running in a similar way. There is job ID, it's running map done, that's working on the reduce part. Word count problem file is the input file there, Anand. That is what we just saw, right? The input file on which we are running the word count program. That is the file we saw. Dayanand, is that clear? So see, let's go up. Let's look at the arguments. Arguments of the program. Hadoop jar, these are the arguments. So a Hadoop jar command, everyone understands. Last time we ran it on TerraGen. This time we are running on our own program. This is the input file which we are going to use. Right, we saw that file which had all that Hadoop written multiple times, and this is the output where we will be outputting the output of this program, right? So let's see the output. Yeah, let's open this output file and see what does it contain. Okay, so this contains part 0, right? Last time also we saw that. Let's look at the output of this. Let's do a cat. Right? So what did we get? We got all those things, right? Whatever, this is what we were trying to do. How many times a particular thing was coming in? Is everyone clear on how this was run and what happened? Is everyone clear? Quickly get a yes or a no. Rahul, you can use any FTP here. There's nothing like you have to move only using FileZilla. Any of the FTP thing can be used to move data. You can even put that file in your email, open that email there and put it there. It's just a data transfer mechanism, nothing more than that. Okay. And put it in your email, attach it in your email, open the file here and then do it. There's nothing like you have to use FileZilla or anything. Okay, FTP, HTTPS, anything can be used. Okay, now everyone is clear with this, guys? Very simple. Everyone is clear? Great, very nice. Now let's see the same thing in using the browser as well. Let's see. This is the output, right? Right. Let's open this file and see the same thing. So this is the output which we got to the input. Let's see the input once again. And let's see if we are able to do that properly. So this was the input file. It had multiple things there, multiple strings, and using our program we were able to get it into that output format which we just saw. Okay, so this is your first MapReduce program. Okay, Now let's try to do the same thing. Let's try to see do the same program, a similar program on our weather data set, right, which we saw. Let's see that program now. Guys, everything is clear in this one? Can I quickly get a yes? Good. I've started getting smileys now. People are happy. Shyam has given me 2-3 smileys. Great. Vijay says absolutely. Great. Now, this was our data set. Let's do. Okay, so because that's the beauty, right? You don't have to worry about those things. We just gave the argument of the input file, right? Yeah, let's see that program once again. Can we see that? Let's see that program once again. So this is the place where you give the path of the input file. How to read, file reading, all those things you don't have to do. That is the beauty of MapReduce framework, right? Okay, Vikas? You did not have to worry how to divide those tasks multiple times. You just wrote whatever you wanted to do. So that's the level of abstraction which MapReduce gives you, right? So think of a situation where you had to write the whole thing in Unix or in any other framework, the same thing to process all this. You would have to do so much coding, right? Here it is very simple. That's why I told you MapReduce programming is very simple. Understanding the concept is slightly difficult. Okay, and understanding the fact that data processing is going to the data is the key, and not understanding this thing, right? Okay. Okay, Amit wants me to explain the main function. Nothing much in there here. Let me explain that. So Amit, what did you not understand that? Write it on the chat window. I'll explain you that part. Okay, so let me go through it once again quickly. So basically, this is my job configuration in which I'll specify my job name. I'll also specify which class will be running, the map, and which class will be running job. This is my main class. Okay, job configuration. Now in this job configuration, I am setting that mapper class using this map.class, right? I set the reducer class using this, right? And then I set the output key class, the output value class. Okay. Then I specify the input format in my const class itself. And this is the class which I'll be using for that. Similarly, I'll specify the output format class. Then I specify file input format and input path, right? Then I specify the output path, right? And then we specify the job client. This will be used by the job track. Okay. And run this job. Is that clear, Amit, now? The function is clear to you? Main function? Any doubts? Okay, great. So everyone is clear with this program. Now let's run the another MapReduce program on our weather data set. Yeah, you need to learn, yes, obviously, you need to learn Java coding. So that is not in the scope of this class. There is a separate set of classes which are available there in your learning management system. You can go through those lectures and understand Java. Yes. Yes, sir. Just a minute. I think just a minute. Let me. Yeah, Vinayak, you want to ask something? I'll just wait for you. While others can remember this data set, why? So the shuffling happens automatically. Okay. The Hadoop framework takes care of that. You can assume that it is the output of the mapper program itself. The sorting and the shuffling is done automatically. You don't have to do anything. You don't have to specify that. Okay. Okay, great. Let's run. You remember this? We had the date and then we had the column IDs and all those things. Let's look at another program which will process this and tell you what is a hot day and what is a cold day. Let's look at that program. So I've copied that weather data set from there, okay, and created a weather data input file called weather data here. Okay, this is what it comes in. This is a text file, right? Okay, and we know that there was this, yeah. Now let's look at our MapReduce program first. Let's transfer this into our VM, and meanwhile let's see it here. This is the one which we got, right? You can do a cat and see if this is the data which we had uploaded. Okay, so this is the data. Now the purpose of this program, which we're going to just show you, is to figure out, to classify these days as max or min days. That was the problem I started with, max, not max and hot and cold days, right? So that was the problem I started with earlier, right? You remember that, everyone? Okay, great. So let's look at a program which will do that. Okay, so basically this is the kind of input we have. This is one of the records, right? Again, we created, what we did was we did a substring. We know this is the max temperature here, this is the min temperature. You remember that readme file in which it was specified which column number specify that. Now we took this, converted into a string, and took the value from 6 to 14 and put it here. So this was converted into a date string, okay, and it came in here. Okay, similarly the temperature maximum was taken from here, 39 to 45. The reason why we did 39 to 45, because it is very much, it can be bigger or smaller than that. And then we did a trim, right? Trim will remove all the spaces and everything, right? And then we convert it into float. Okay, so if we take that, from this point to that point, this is the maximum temperature and this is the minimum temperature. Okay, so this much is clear to everyone, that we created three variables: date, temp max and temp min. We did not do anything else here, right? Right? And if a day is actually greater than this, right, we put output collect as hot day and date. So this is what we output. Okay, and if it is a cold day, then we output this. Let's see how does the output look like. Okay, so basically all these days are hot days, and then we have the temperature along with it. Obviously this hot day will not be, the temperature will not be this will say 40 or 50. Okay, fine. So this is the output we'll get, or we'll get the cold day, date, and then the temperature. This will be the kind of key value output we'll get out of this. Okay, now this was done in our map function. Let's go to our reduce function. Now this is an exercise for you. Okay, what you have to do is implement, use this program. You can create this program on your own. Okay, and then I want you to tell me which is the hottest day in a particular year. Okay, that is the output I want, right? So I'll have to do something here which I will not do, I'll let you do. Okay, is that fine? So this program is not doing anything. Okay, it is just outputting the same thing. So in this case, reducer is not doing something. But if we haven't done this, we will leave it to you, okay, to do this exercise. Is that fine, everyone? right? I want everyone to try this program out. Now, if I run just this program on that data set, let's see what is the output. So we should get such outputs using this program on that data set, right? Let's create the jar file once again out of this. Now word count, export, create a jar file, name of the jar file. Let's name it weather.jar. Okay. Do a next. Class name. What is the class name? Weather data. And then we finish. So this is my Java archive which has been created. Let's move this Java archive. And see if we are able to see it here. Yes. So Java archive came in here. Now let's run our same command. Before that we need to check the input path of the data. Let's see if the data exists there. The weather data exists there. Let's open this data and see what is there inside this. So this is the data, right? Is everyone fine till now? Everyone is following this? Keep on writing yes. Okay. Now next, okay, cool. Then we do the Hadoop jar, name of the class, and then the input path. So large data set, so let me find the path. Yeah. Okay. Input path and then the output path where I want my output to be generated. Okay. So my MapReduce is running now, and in a while we'll just check. So it is taking some time, it took some time, it is done, right? So this is the output which we gave. Let's see what is the, okay, now let's look at this part 00. Hadoop DFS minus cat. Okay, so it gave so many cold days. Did we get any hot day? Probably there was no day which was beyond 40, so we got that. Okay, so is that clear to everyone, guys? This is how we got it. Now the next thing which I want, can I get a quick yes from everyone, is if everyone is clear with this part? Abhishek, Vinayak, Shyam, Rahul, Amit. Okay, great. So now we have done 2 MapReduce programs. There is no way to confirm if the input file is correct. I mean, what is the input file? Well, see, input file corruption, those are there different techniques like checksum and all will be there, right? So where you can look at whether the input file is corrupted or not, right? But that's beyond the scope of Hadoop or MapReduce, right? That check has to be done before that. Okay. Vikas. Okay. So now the exercise for you is to calculate which is the hottest day and the coldest day out of this. Okay. For that, the logic has to be written in the reduce program. I am not going to spoon feed everything. I am not going to teach you that. You have to find that out on your own. Is that fine, everyone? You'll try it out. If you need help, you can contact the support team. I don't think you'll need any help there. And I want everyone to actually try that out. Okay. So next time we need to make sure that everyone has done that. And in the next couple of days itself, you should do this and send it across to me. Copy me also when you send it to the support team. Okay. Thank you. Unless and until you do it on your own, unless until you are able to spend time, all this will go waste. Okay. Now let's look at something more. Okay, so we have understood map and reduce. We've run a program as well. Let's look at some of the other things. Okay, and if you don't mind, I'll probably take a 2-minute break, a very quick. I'll have some water. I did not sleep very well last night, so I'm having some trouble today. Okay, do you mind if I take a 2-3 minute break? Vijay, Abhishek, it's late for you. Can I take a 2-3 minute break, Abhishek? Shyam doesn't. Okay, thank you very much. Yeah, thank you very much. So just a 2-3 minute break, and I'll be back. Okay, thank you. You can keep thinking about what you've learned today. Keep making notes for your own self, and you can ask questions if there's something which you had, which you think you're not very clear of. Write that in the chat window. After I come back, I'll answer that. Okay. Okay guys, I am back now. Okay. Rahul has sent me a question. So Rahul, see, there will be a structure to any input, right? All logs will be generated with some structure. Okay. It may not be very clearly defined. It can be a delimiter thing. It may not be exactly same, but there will be some kind. This is the data which we've used is actually a production data, right? I have not created this data. This is the data which I picked from a website only, right? And it is the actual data which is being dumped. So whenever you think of creating a log, you have something in your mind and then you dump a log, right? So this kind of data will have this at least this level of structuring will be there in the data, right? It will be a text file. It will not be completely rows and columns and everything, but this level of structuring will be there. Some level of structuring will. You need to figure out a way to understand what is the key, what is the value. Is that fine, Rahul? Okay, great. Now let's come back and okay. Everyone is able to hear me, Abhishek and everyone, and the screen is also clear to everyone. Let's come back to our presentation. Great, thank you. Now let's look at this diagram once again. Okay, not this one, but the one before this one. So now all these things are clear to everyone. Where is what happening? This diagram is clear to everyone. Can I quickly get a yes? Very nice. So everyone is a MapReduce expert now. Can I get a quick smiley if you think that you have understood MapReduce? Shyam has given me a smiley. Dayanand has given me a smiley. Very nice. Just 2 hours time. Great. Everyone has given me a smiley. Thank you very much, guys. Thank you very much. Really appreciate that. Okay. Vinayak has given me 2. Okay. Cool. So let's go ahead and let's see what's in. So this part also everyone is clear quickly. Yes. What are the biggest advantages of MapReduce? Not only data processing, data locality optimization. Now this is in technical terms, what do we call this? Let me write it for you. Now you may be asked a question, what is data locality optimization and how do we achieve data locality? Okay, so this is very simple and this is what is data locality optimization. So whether you want to impress your boss, you want to impress your girlfriend, or you want to impress your father, okay, or you want to impress your employer, this is what data locality optimization is. Okay, this slide explains you that. Okay, I did not use that word earlier because I did not want to confuse you. Okay, but if someone asks you that question, what is data locality optimization, don't get terrified by that. Okay, if you explain this, people will not understand this properly as well. Okay, you will be an expert in this now. So you are an expert in data locality optimization. Is that fine, guys? Can I quickly get a yes or a smiley or whatever you want to tell me? This, for me, not the Java code, nothing. This is the most important aspect of Hadoop or MapReduce. This is the most important thing. The Java programming is not, the map function is not, the reduce function is not. Some things which you're going to see next are not. This is the thing. So if you understand this well, if someone comes to me for an interview, if I ask him, boss, how does this manage? What is the biggest advantage of MapReduce? People will tell me it is parallel processing. Yes, it is. But this is the most important thing. I'm stressing on this again and again because I want everyone to remember this. Okay. Thank you very much. Okay, great. Let's move ahead. Let's see one more thing, which I'm sure everyone has this question. Split. In the first class also people asked me, does the reduce on a node get invoked only once? Yes. Okay. So everyone had this question right in the first class, that what are these input splits? You remember we had a long PPT series of PPT where point 4 was create input splits. Everyone remembers that? If you were in the first class which I took, step 4 was create input splits. Everyone had that doubt. What is this input split? Right? At that time I told you I'm not going to answer that now. Okay. Now the time has arrived. The moment has arrived. Okay. So let's get that answer now. Okay. And if you do not get this answer today, you will never understand it in your life. So it's very important. Ask all the questions today. This is your moment of glory. You should understand how do input splits work. Okay, great. So ask as many questions as this. Next 2 slides will be dealing with that only. This is also a very important concept to understand. Okay, it might take 15-20 minutes to understand. So just hold back. Okay, right. So let's go below this and let's see what is this. Okay, now we have input data. These are HDFS blocks. Everyone knows what is the size of a HDFS block, typically 64 MB, right? You remember that, guys? And these are the physical blocks, right? We've been talking about them for a long time, right? There is a physical division. The input split, though I use the word that we'll be doing it on a block in the earlier slide, is not exactly same, okay? It is more or less similar, but not exactly same. This is a logical division, okay? So this is a logical division of the input, not the physical division, okay? Let's see what is the difference and how do we do these splits. What are the considerations we should think of while we do these splits? Very important slide coming up next. So basically this is how it is done, right? Now this is your block boundary from this place to this place. Physically 64 MB got over, your block got over. Nothing to relate to the block, to the record. While from this point to this point is your logical block boundary. Okay, so this may be slightly more than 64 MB, it may be slightly less than 64 MB. This is where we split. Okay, this is the split which happens. Now why do we want to keep that very similar to the record boundary, the block boundary? Can anyone tell me that? And this is a slightly tricky question, but if you've understood what we have learned till now, including whatever we just saw, then you will be able to answer that question. Now the question is, why is it important to keep the split boundary or the split size similar to the physical division or the block size? Why is it important and why would you do that? That is the question I'm asking. I want everyone to think about it. Again, the same. Can anyone answer that? If you're writing about it, just quickly give me a yes. Okay, Shyam has given me an answer. Anyone else who wants to answer that question? Why do we need to keep the block boundary, physical block boundary and logical block boundary, the split size similar? Very nice. Very good, Abhishek. Very good. Very good. So you've got the point. Data locality optimization, right? Anyone else who wants to answer that question? Abhishek, I'll read out your answer, and that is probably the perfect answer, the most perfect answer I've ever got in this class. Thank you very much. So I'm really happy that you people are able to follow what I'm trying to make you understand. It gives me immense pleasure. For an old man, this is all I can boast of. Very good. Okay, anyone else who wants to answer that question? I have got an answer from Abhishek, which is right. Shyam's answer I did not really understand very well. Maybe he's also saying the same thing. But I want Vijay, Vikas, Amit, everyone to think about it. I'll give you 1 minute. Don't worry. I'm not in a hurry. And we'll be able to finish this class in another 35 to 40 minutes. So do not worry that the old man is taking so much time. I want to finish this off and go and meet my girlfriend today on a Sunday. So Rahul, please answer this question. Okay. You guys got angry with me. You're not answering that. Only Abhishek has understood that. Okay, Vijay is answering something. Good. Rahul, I want everyone to write. Okay. Sure, Rahul, keep thinking. Okay, first thing and then write. 1, 2, 3, 4, 5 are not splits. These are records. Split is from this point to this point. The red on the upper side. Block is this. Okay. Okay. So anyone who is not writing and only thinking other than Rahul? Very good, Amit. Amit has given me a good answer. Thank you. Very nice. Guys, can you please keep these phones away from the class? And Skype today, thankfully Skype pinging is not happening. Okay. Has everyone thought about it? Shall I answer that question? I'll not answer. I'll let Abhishek answer that question. Abhishek, do you want me to unmute you? You want to speak? I'm very happy with your answer. And I want you to explain that. Shall I unmute you? You have a microphone there? He's not responding at all. Abhishek, are you able to hear me? Okay. Maybe he has dropped off. Okay. Guys, okay, no problem. Abhishek does not have a microphone. Okay, everyone is there. No problem. I can understand. It's very late, so I can understand, Abhishek. I'll not take much time now. So basically, I'll just read out Abhishek's answer. So the map doesn't travel over multiple data nodes. Okay. So now this is what we wanted to do all the time. There is a guarantee that one block will be available in a single data node, right? Right, there's a guarantee there that 164 MB block will definitely be available in the same data node, right? So even if we had say 2-3 blocks, okay, if the split was spanning over 2-3 blocks, there's no guarantee that the map will be running on the same data node or not, right? So that is why we try to keep the record boundary, the split boundary similar to the block boundary, okay, so that we can achieve the maximization on the data locality optimization. Okay, is that fine, everyone? The answer is clear to everyone? Amit, you are also right there. Vijay, is that clear now? Vijay, very important concept. This has to be understood by everyone. Okay, so I'm saying, okay, let me explain that once again. So Rahul is saying superb. Okay, I'm explaining it again. Okay, now see, split is a logical division. You can divide the record logically at any boundary. You can do at 2 block boundaries as well. This complete thing can also be one split. But my question was, why do we want to make sure that the block boundary and the split boundary is similar? Okay, not exactly same all the time, but similar. Okay, because of the fact that it is guaranteed that one block will be there in a single data node, right? This is something which everyone understands. One block will be in the same data node. Satyam, are you there with me? Satyam, I have not got a response from you for a long time. Looks like we've lost you. Or are you watching something else? Okay, no problem. Looks like Satyam has slept off. Okay, so okay, so now that was the guarantee which we had, that the one block will be available in a single node, right? Now if we create a split which is similar to that block boundary, there's a very good chance that that map job can be run on a single data node only. If we had this split over 2 data blocks, okay, then there is a chance that this block is in one data node, this block is in a separate data node, so map has to span 2 data nodes, right? So, and we want to keep the data locality optimization, so we want to keep the record size, the split size similar to the record size or the block size, right? Is that clear, everyone, guys? Now it is clear. And thank you very much for Abhishek for catching that, and as well Amit. Great. Anyone who is not clear with this, it's a very important concept. I can spend 2-3 minutes more on this. No problem at all. Okay, can I quickly get a yes from everyone if everyone is understood? Very nice. So now Vijay is asking about this edge case. So yeah, see, there's a good chance that this part of the block will also be there in the same data node. If it is not, then you'll have to span, right? But there's a good chance that this block, even if you miss this part, this will be more likely to be there, because you will be storing data in a similar fashion, right? Yes, exactly, Amit. That's right. Yes, Vijay, that's exactly how it will happen. The input splits we will be specifying. So yeah, if it splits in two different blocks, then most likely that block will also be there in the same data node only. So the map will be running on the full thing, right? So there is a good chance that this, even if these are on two blocks, these two blocks are on the same data node. There's a good chance. So this will be found here most likely. If it is not, then probably the split will happen here, right? Instead of having it here, because this part will definitely be there, right? It will be the Hadoop framework which will identify that, and then run a map on that, right? You don't have to do that. So if the word say this 5 spans two different blocks and two different data nodes, then most likely what will happen is that the split will happen at this point on a logical boundary. It is not required to be more or less, right? It can be anything. Is that fine, everyone? Vijay, is your question answered? Okay, great. Let's move ahead. Let's look at some of the other things, important things like, okay, now this is the flow. Now we've understood everything. Let's look at this flow once again very quickly, and two important things which I want to tell you in this slide. Okay. Okay, so I'll just tell you two important things in this slide. You go through this slide for another 20 seconds. Take 20 seconds to go through this, and then I'll explain you two important things which I want to tell you. Okay, so basically I'll walk you through. So this was the input data. This is node 1, this is node 2. This is your split. This is the map which ran on it. This was the data, intermediate data, which was dumped by. Yeah, please ask that. I'm explaining this. While I'm explaining, you can ask that question there. Okay. Now, this is the intermediate data. This is the map output. Now, the important thing here is that the map output is stored where? You remember we had a parameter called tempdir in the mapred.xml. You remember that? Everyone remembers that? Very good, Rahul. Abhishek, you remember that? Everyone remembers that? Very nice, very nice. So that is where this output will be stored. One very important thing, this is not stored in the HDFS. This will be stored in the local disk of the data node. Okay, this is a temporary thing. Storing it in HDFS will be an overkill. So this part is not stored in the HDFS. Okay, so the way it happens is this is running on a single node. Okay, the map job runs on the input split. The output of this is an intermediate output. This will be dumped in the local disk. Okay. Vijay, just give me 1 minute. I'll answer that question. Okay. In the local disk, this will be stored. Then the shuffle process will be done by this guy. Okay. By Hadoop. Then the intermediate data will go to the reducer. This can be running on a different node as well. Reducer. Okay. Most likely, if it is possible to run it on the same data node, very good. That will achieve the maximum localization of the data. Okay. Right. If it is not possible, then it will be run it somewhere else. Right. Then this reducer output, whatever comes out of this, this is not stored locally. This output goes into the HDFS. We've already seen this output in HDFS, right, guys? We saw that part 00 was getting stored in the HDFS. Is that right? Everyone remembers that when we ran those programs just a while ago, right? So this output is stored in the local machine, local hard disk, local disk. This output is stored in the HDFS, and this will be replicated as well. Okay, is this clear? Is this clear to everyone? Two important things in this: where are these map and reduce jobs running, and where are this intermediate data and the output data getting stored, right? Great. So this is also one thing which you may be asked. I mean, if you're going for an interview, you may be asked, but I mean, see, the important thing is that you should understand these things. Interviews are fine. If you understand the MapReduce, if you've understood whatever we've discussed today, probably you have become very few people in this planet Earth who know MapReduce well. So be happy about that, okay? Because I've interviewed so many people, hardly anyone understands this part well. So you should be happy. But don't think that you will retain this unless and until you practice all these things. So go back and write all these programs as well, right? Okay. Thank you. Now, okay. Vijay has a question. If the file does not actually get split into smaller files, it is logical and it will in block representation and made available to Node for processing. Vijay, I have not understood this question. Do one thing, write it up, give it to me in an email. I'll answer that there. Okay. I don't want to actually stop here on this one. I think most of the things are clear there. So I'll probably answer this offline. Is that fine, Vijay? Vijay? It looks like Vijay is not responding. So let me go ahead. Okay. Let's go ahead and see what are the other components. Very good question, Vijay. Very good question. Does the shuffle process aggregate all the key specific data and involve the reducer per key? Now, this is something which we're going to very soon we'll get to know that. Okay. So keep this question with you. Very soon you'll get an answer to that. Okay. That will be explained in today's class itself. Let's move ahead and let's see what are the other things. Now there are two more things. Till now we've just looked at map and reduce. There are two more things which are there, very important things, which is called combiner and partitioner. Okay. So we will look at a program which will explain the combiner and a partitioner. Combiner is like a mini reduce program which can be run in the map phase itself, wherever possible. Okay, wherever possible is very important here. As far as possible, we'll try to write a combiner. We'll do the reducing job also at the map part. We'll just see an example. Partitioner is something which will answer your question, Vijay. So I'll explain that concept. Just on this slide, just try to understand that two more things, combiner and partitioners. Okay, I'll explain that in detail with an example. So don't worry about that. Okay, Rahul. So everyone has understood that two terms which I've understood, which I've explained, combiner and partitioner. But let's look at what is the combiner. Okay, so combiner is basically a mini reducer. What will do is it will do some of the activity which can be done on the reducer at the map output only, before giving it to the reducer. Okay, so further making sure that data locality optimization is achieved. To minimize the data movement, we write a combiner. Okay, I'll show you how the combiner works in just a while. Okay, so before it will perform a local reduce on the mapper output itself before distributing it to the mapper result. Okay, let's see an example. So we know there's a block A, block 2. Mapper will give me this output, B1, C1, B1, C1, right? Here. Now, at the mapper output itself, before the shuffle happens, if I can do something like this, I'll probably be shipping less data, moving less data, right? So if I know that B has come here twice, I'll do a B2 here, C1, D2 and E1, right? Similarly on this part, the combiner will give me this. So combiner implements the same function as the reducer. Okay, it is the same function at reducer, and then you will combine these, and then the output will be sent to the reducer. Okay, is that fine? Now, very important thing to understand here is that the combining part happens at the same data node where the map was running. Okay, so basically if it is possible, but can you think of a situation where this will not be possible? So it is again the function dependent thing. What are you actually doing with the data? So if this is something like this, it is possible. There can be some situations where a combiner is not possible at all. Can you think of that? Before that, has everyone understood the concept of combiner? That instead of shipping the data, if I can do something like this here, Okay, I'll be giving less data to the reducer, right? The reducer function can be run a little bit on the map output itself. That is what a combiner is, right? Now, is that clear to everyone? Can I quickly get an answer? Yes or no? Rahul, you've understood that part? With this example? Rahul? Amit? Vikas? Everyone has to answer this. Very nice, Vinayak. Thank you. Everyone has understood this, right? Great. Now, Amit, I have not got an answer from you here. Combiner is doing consolidation. Very nice. Now tell me a function. Now this was a summation function. Combiner was used, right? On a max function also a combiner can be used, right? Because the max of this, if I get a max of this out of there, right? The max of this will, same thing will remain there also. Can there be a function on which combiner will give incorrect results? Yes, right. Sorting is anyways done by so sorting function will not be a reducer kind of function. It will be done directly here. Think of a function like mean. If you take an average, right? Exactly. On an average, this will give a wrong result, right? So combiner cannot be used everywhere, but wherever it can be used, we should take advantage of that. Okay, is that fine? So what will this achieve? You may say that, okay, the output remains the same, but the same concept of data locality optimization applies here also. So now you are clear why did I stress so much on data locality optimization? Why did it say that data moving processing to the data? So here also we are trying to move the further processing to the data, right? We are trying to achieve more data locality optimization, right? Is that fine, guys? Is that okay? So wherever possible, use the combiner function. If it is not possible, then we'll not use it, but wherever possible, we'll use it. Now let's see in our Java code that how do we make the use of the combiner function, right? Let's see that. Let's open our Java code once again. Just a second. Okay, so basically see, we know that the function is same as reduce. So what we just do in this case, set combiner class to reduce class. Okay, so MapReduce framework will understand that you want to use a combiner thing. Now this intelligence, what your function is with you. So if you are using an average function, you should not set this, because otherwise you will get incorrect results. If you are using a function like min, max, summation, where the function, whether you do the reduce at the reduce step on the full data or on a part of the data, then you can use this. So this intelligence cannot be expected from Hadoop. This intelligence has to be given by the user. So if you want that, you can set the combiner class a reduce class. So this combiner thing will come in between, right? Is that fine, guys? The output will still remain the same. There's no change in the output. That's what we wanted to know. So even if you run this program, you'll get the same output, but it will be faster, right? Guys, is this part very clear? The combiner functionality is clear to everyone? I want a yes or a smiley from everyone. And I also want to know if how do you set this combiner class is also clear to everyone. Yes, Rahul, exactly. So combiner is a sort of mini reducer that consolidates the output before the final reduce step to achieve data locality, right? Correct? Now combiner in this case, right? And in this so what should be the consideration when you think whether I should use combiner or not? Now if you can say in your data set, if you can say finally whatever I want, if that result will be true on a partial set of the data, and the same thing can be extrapolated to the full set of the data, then the combiner should be used. If you say that the result, if I do a partial, that function, run a function on the partial set of the data and the result will be different, then you cannot use. For example, the example which Abhishek gave us, on an average it is not possible to use a combiner. It will give erroneous results, right? Is this clear to everyone? Quickly. Max and min can also be used. Mean cannot be used, right? Statistical function like mean, I mean, very simple thing. if on a partial set of the data, you can use the same function and get similar results. If you extrapolate that and combine those results together, then it is yes, combiner, otherwise combiner is no. Okay, clear? I want a smiley from everyone if this is clear to everyone, or some acknowledgement from everyone, Vinayak and everyone. Very nice. Thank you very much. Okay, so the concept of combiner is clear to them. There is nothing more than that. You don't have to write any separate code for combiner. You just have to set whether I want to use a combiner or not, and that will be based on your assessment on what function or what is the functionality you are doing. Well, why max and min will not be on full data? How will it give wrong result? If I do a max of say 3 things and I take that out, right, and then I use it, say let's take an example. Amit is saying max and min will not give the result. Okay, let me tell you how. So I have 1, 2 and 3 as the one set of inputs, then I have 5, 8, 9 as another set of inputs. Amit, just for you. And then I have 1, 5 and 6. Okay. Now one way is do a max on all these things together, which will be done in the reduce function, right? Here what will be done? Output of the combiner will be 3. Output of the combiner here will be 9. Right? And output of the combiner here will be 6. Right? Finally, the reduce will get only these 3 things, out of which it will give the result 9. Right? Is that clear to everyone? Amit, is that clear? I mean, again, yes, reducer has to do processing, but only on this data, right? 396 only. Combiner is not taking away the reducer. It is just making sure that least amount of data reaches the reducer wherever possible. Okay. Got it? Great. Everyone is clear with this? So basically, if this was the mapper output, right? This is the combiner output and this is the reducer output. Okay, everyone is clear with this? Guys? Great. Thank you. Thank you very much. So combiner is clear. Let's look at the other concept which we call as partitioner. Now what is partitioner? Okay. So Vijay, your question. Vijay, can you write that question once again where you were talking about single key thing? That question will be answered by a partitioner. Okay. Now, don't worry about this diagram. I don't like this diagram much. Okay. Now let's take an example where you know, let's take a real life example. Okay. Let's see if I know that I want to, in that word count program itself, I know that I want to calculate the number of occurrences of Hadoop. Okay. So what I'll do is, and if there are multiple reducers running, there's no guarantee on which reducer different Hadoops will go. So if I know that a particular thing is, I know which key I'm interested in, then I can use a partitioner to redirect all the mapper outputs to that particular reducer. Okay. I'll show it to you with an example that will make it very clear. The only thing is, say for example, if I know a specific IP address in my server log and I want to do the result for that in a single place. Okay. So basically what I'll do is I'll use a partitioner to redirect all the map outputs pertaining to that key in a separate reducer so that I get result together. Let's look at this with an example. Java example will make it very clear. Let's look at this with an example. I know some things are not clear here with that monologue which I gave you. I think we should have a better slide there. Yeah. So see, so you remember this example, right? Now what I'm doing here is, I'm saying in a partitioner, I'm saying if my key equals Hadoop, then return 0. If my key equals data, return 1, else return 2. Based on these values, I will redirect this data to a particular reducer. Okay. So this is one step. Output types of mapper should be arguments to the partitioner. So this output from the mapper comes to this, and if this key is equal to Hadoop, then it will go to reducer 0, then otherwise it will go to reducer 1 if the key is output, and if the key is anything else, it will go to 3. Okay. So let's see. I know that there are 3 reducers running here. Okay. Here what I'm doing, conf set num reduce task to set to 3. So basically this is the other change which I did. So instead of running 1 reducer by default, I am running now 3 reducers. And I'm using my partitioner, I'm trying to redirect the output of, using my partitioner, I'm trying to redirect the output of one particular map to particular, based on the key value, consolidation of the key, I'm sending it there. Okay. And the other change which I did is set partitioner class to my partitioner.class. These are 2 changes I did. Let's run this program and then it will become very, very clear to everyone. Okay, let's run this program. Let's export this, create a jar file out of this. Let's call it partitioner. If it is not clear till now, hold on for 1 minute. It will be very clear. Let's export this. So we have the jar here. Okay. Now what did we change in this? Just a second. We changed 2-3 things. One, we added a partitioner class. Then we made sure that instead of 1 reducer, we are forcing to run 3 reducers. Is that clear to everyone? That is the thing which we did. Can I quickly get a yes from the code? From everyone? These are the 2 things which we did. Guys? Yes? Good. Thanks. And let's see what, and then we said that based on the particular key, the output should go to the particular reducer. Now let's see if that is happening really or not. Let's run this program on our same word count data set which we were using earlier. Okay. This is the input file. This is the output path. And let's run it. Let's see what happens. Okay. So map is done. It's in the reduce phase right now. It's running for some time. I don't know what's the, okay, done. Let's look at what were the outputs here. So basically this is the output directory we specified. So here how many outputs will be created? 3 reducers, so 3 outputs, right? Part 0, part 1. So what is the expectation on your side? What will be the content of part 0? I want an answer, guys. What will part 0 contain? Very good, Vijay. Very good guys, very good, very nice. So everyone has understood the concept of partitioner. So it will contain, let's see, what does it contain? Let's go to the browser history, let's see. It contains Hadoop as expected, right? So basically, and let's see what does part 2 contain, part 0 contain. It contains different occurrences of data, right? And everything else is there in the part 3. Is this part clear to everyone, guys? I want everyone to answer in a yes or no. So the functionality of partitioner is clear to everyone. Why do we need a partitioner? And where do we need a partitioner? Where we want to make sure that a single key will be processed at some place. For example, if I know that there is a web attack on my website, I want to consolidate all the occurrences of that particular IP address together, I'll probably run that. Okay, guys, I want an answer from everyone. This is the last part of the class, and we'll be able to wrap it up in another 5-10 minutes. So I know, Abhishek, it is too late for you. You're sleepy, but thanks for the answer, guys. Okay. Dayanand, Amit is not clear. Amit, what is not clear? I want you to write it up. What is not clear? So basically, what we did, we made sure that we write three. We'll be using 3 reducers. Well, wherever we need. See, if you are okay with having partitioner is required, wherever I want to consolidate all the particular keys together and run it in a single reducer. See, otherwise, what you would have done. Now, this also contains configuration. The other reducer also contains configuration. Okay, different reducers might, if you run 3 reducers and different reducers contain different things, and then you'll have to combine that result later, right? So instead of doing that, you can use a partitioner to, if you know that you're interested in some particular key's result, you can use it as in the partitioner. Is it clear now? Amit? Okay, great. So I think some level of Java coding is something which you need to understand, but then otherwise so everyone is clear with partitioner now. Can I quickly get a yes once again from everyone, or a smiley from everyone? Very nice. Thank you very much. Okay. So in today's class, yes, a more efficient way of map reducing using partitioner. Okay. Now in today's class, where did we start? We started with what is the need of MapReduce. Then we looked at what are the traditional ways of doing that. We looked at grep and match and all those things. Then we asked everyone then we also talked about critical path. Then we asked everyone what are the challenges in doing all these things if we had to write the program. Then we told you that okay, Hadoop framework takes care of all that. Then we also understood the map and the reduce process. We understood the shuffling process. Then we went to data locality optimization. Then we talked about that, right? Can I quickly get a yes? This is a revision. I'm almost towards the end of the class. I'll just explain one more thing after that. But before that, I want everyone to keep telling me yes, right? So we started with the traditional ways, right? Then we moved on to the challenges which will be facing the traditional way. The size of the data becomes huge. Then we talked about that the size of the data. If the size of the data has become huge, don't worry. We can split it into multiple parts using the traditional way of non-MapReduce. Then we saw the challenges there. We have to maintain which machine is running what, the job scheduling, failures, everything has to be taken care of, right? We did that, right? Can I keep getting yeses from everyone? And then we figured out then it will become too cumbersome. Everyone put up their hands that I cannot do it. Abhishek said I cannot do it. Vijay told me I cannot do it. A lot of people did not even respond. Then we thought that who will come to our rescue? Then we came to MapReduce. We figured out, okay, MapReduce can help us there, right? Then we looked at what is the map and the reduce process. Then we understood where the map runs, where the reduce runs. Then we after understanding the process, we ran that word count program quickly, right? Then we looked at the weather data set and we ran that program on finding out the cold and the hot day. Then I gave you a homework that, okay, you have to run this program and find out the max and the min temperatures in a year. That is something you will do, right? Yes or no? Only Rahul will do it. I want everyone to try that out, okay? Then we moved on, we looked at the data locality optimization part where we looked at that figure where we saw the data will be data movement we have to restrict, right? And with that concept, we understood that is the most important part. Then we looked at how the splits are done, right? We moved on to that. We looked at how the splits are done, the record. We understood the difference between the logical boundary and the input split and the block boundary, right? Right, guys? We understood that part. Then we looked at the various considerations which you have to take. When we asked this question, why do we need to have the split boundary and the record boundary similar, right? We got very good answers there. Then we moved on. Then we looked at, what did we look at after that? We looked at the concept of combiner and partitioner. Then we looked at just to achieve more data locality optimization, we can use a combiner. Then we also figured out that combiner cannot be used everywhere, right? I want yes from everyone. Then we looked at a few functions where the combiner can be used, right? Then we looked at few functions where the combiner cannot be used, right? Right, guys? Then the average was one such function where the combiner cannot be used, right? Then we looked at, what did we look at next? We looked at the utility of a partitioner, right? We also understood how the combiner helps us in achieving more data locality optimization, this example which we saw, right? And then we looked at the concept of partitioner. Then and also we looked at in our Java program that for setting we don't have to write a separate combiner function. We'll just set the reducer function as the combiner class. You remember that, right? Everyone remembers that? What do we need to make change in the Java program for setting the combiner class, right? Just set that combiner class to reduce class, right? Then we looked at the partitioner example. In the partitioner example, first we set the reducers to number of reducers increased to 4, 3. Then we created a partitioner class. In the partitioner class, we implemented that if some key based on the key, we were redirecting the output of the map to a particular reducer, right? Keep on writing yes, guys, if you understand that. Then we looked at, okay, number of reducers we set, right? Then we went ahead and exported that, and we ran that program again. We saw that there were 3 reducer outputs. The first reducer output contained the occurrences of Hadoop, the second contained the occurrences of data, and the third contained everything else. So we understood why a partitioner is also required, right? Is that clear, guys? Everyone is clear with this? So whatever we have taught today, everything is crystal clear. No doubts on this. Any doubts, please ask me now. Very nice. Thank you, Shyam. Thanks for the smiley. I'm just going to cover one more concept which will take just 5 minutes. After that, I'll leave you. Okay. So this time we've been on time. No. So Vinayak, when we set, good question. We have already set number of reduced tasks in mapred.xml. So whatever we set in Java class, will it override? No. So that parameter is for how many reduced tasks can be run on a single data node, and not here. This is number of reduced tasks you will be running in your program. Is that fine? That is for the data node. That specification is for the data node. How many reduced tasks can be run on that data node? That is that thing. Is that clear, Vinayak? Good, thank you. Is everyone else also clear with this thing? There was a parameter mapred.xml, that number of reduced tasks, right? That is for data node. That is not for this program. This is your user level change, right? That is based on your capacity of that data node. You will be setting up how many reduced tasks will be run on that. Okay, is that clear to everyone, guys? Very good question. I mean, I'm sure some people may have that doubt. Thanks, Vinayak, for asking that. Thank you very much. Great. So everyone is clear with that. So everyone is clear with the map reduce. Today, everyone is happy with whatever they have learned. You feel that you have understood everything in MapReduce today? Good, very nice, thank you. So that is all we have in MapReduce. Just one more thing which I want to tell you is one of the input format I want to cover. Okay, which is the key value input. Am I audible, guys, now? Can I quickly get a yes? Okay. 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 Great. So basically, yeah. So now, uh, yeah, I'm coming to that only. That is what I'm trying to explain here. So the input format slide actually was showing you that there are different type of input formats. The one which we saw earlier was just a simple text format. Now we're trying to see if we have a key value format here. Okay, a key value format will be that if the input already has something like a key value pairs, for example, something delimited by space or delimited by, say, uh, a comma. Okay, a comma separated format. If I know anything before the comma is the key, everything after the comma is a value. So initially, you remember in this word count program, we had to write this tokenizer, right? We had to write this tokenizer to split that data into keys and values, right? Now, if we have a key value class, if we have a key value type of input format, we don't have to do that. We'll just parse this, okay, and we'll understand that, okay, this is the key and this is the value. If I already know that it is a delimited value. How do we set the delimiter? This is where we set the delimiter. So we say that conf set key value separator in input line as space. Okay. So if we set this here, then on this output, we will already know we don't have to use the tokenizer. So that is the difference between a normal thing and a key value thing. In this, we just use it and we create a key value outputs directly from here, right? Without using the tokenizer. Is that clear to everyone, guys? Great. So yeah, so this is the difference. I mean, in this case, we did not have to use the tokenizer. By just setting the key, if we know that we can separate this out like this, we can take the advantage of this. Okay. So that is all we have today in today's class. Okay. I want you to actually go back, practice these things on your own, then only you'll get the feel. Okay, if you have any questions, you can route it to the support team. They'll be able to answer all the questions on this slide. Also, the recording of this class will be available in your LMS so that you can look it there. Okay, fine. Anyone has a question, I can answer it now, or we can just sign out for today. Okay. So guys, if you do not have a question, then you can just fill in the survey form and then you can go. Amit, the input format gives you an advantage if you know that we have a key value input format. If you already have that, you don't have to write that code of the tokenizer. For example, in this word count program, initially we wrote this tokenizer code, right? Where we said that everything which comes in will be tokenized, right? In case we know that, okay, this is separated by a space in this program, what we can do is this. We can separate it out like this. Okay. Insert this and then we get rid of that tokenizer code. Okay. Thank you, Shyam. Thank you very much. You too have a great day today. And folks in the US, thank you very much for joining in. Thank you, Vikas. Okay, Amit, is that clear now? Okay, great. So go ahead and practice these things. Otherwise, you will forget all these things in a few days. Yeah, you will get the class recording. Yeah, the class recording will be there in your learning management system. No, yaar, in your learning management system, in your class recordings will be there. Okay. You found Pradeep there, Amit, because you were in Pradeep's batch earlier. So ask the team to move you to my batch. Then you will find that. Then let me show you. So yeah, you can write it here. You can write it to the support team. They'll do that. Okay. Please specify that you are in the same day you are in, because there are multiple parallel batches which happen. The Pradeep probably is taking one. You are taking my class, so you will get this one. Okay. So you'll find in week 1, week 2, week 3 class recording. Don't have to tell the batch number here. Just Amit, just specify that you are in 15 June batch or whatever batch date it was. Okay. Okay, and you tell them that you attended MapReduce class with Abhishek today. You want them to be moved to the Abhishek's batch from the LMS side also. Okay, batch ID you need not know. Okay. And also tell them that you are getting Pradeep's recording so that they'll know that what context you are talking in. Okay, Amit? Yeah, Vinayak, please tell me, sir. Vinayak, are you writing something? Should I wait for you? Guys, whoever, I am done with the class. If you do not have anything, you can leave now. Okay. Yes, Vinayak, you'll get all these examples are there in the LMS already. Right? These examples are already there in the learning management system. Let me show you where you will find them. You can go here. Guys, can someone log in with this admin ID or something? Can you log in with this ID? Thanks, Vineet. Show it to everyone. Where we'll find these examples? So this is where you will find all these examples and many more. Okay. Partitioner will be updated in this. They're saying partitioner is not there. It will be updated. Now this video shows you how to create that jar file. Okay. Let me play this for you. Very good music. So this is how you will create a jar file. Okay. So Rahul, this video is showing you that. Here, now next. So this shows you how everything in just 3 minutes, everything is captured here, okay? I don't know if you guys are able to hear the music, but that's a very good music as well. And then you look at the output here. Okay, great. So you run this, yeah. So what you can do is when you run this file, you'll hear the music as well. That's a very good music. That's why I listened to it throughout. Okay. So yeah, I think